One topic that has recently become popular on the AP test is related rates. And it's not the related rates that we are used to, it's more a differential equation related rate. So I'm going to create this video to help you guys through it. So when you get a problem like this, you will notice that it gives you a dH dt or dB dt or dG dt. Basically, your derivative has a dt, a derivative in terms of time. And oftentimes, they will give you the dependent variable inside the derivative. So it kind of looks something like a function where we have dy dx equals y squared, where we know that the independent variable is x, but the derivative is given in terms of y, the dependent variable. So you know that it's a differential equation related rates. So they're going to give us a really long paragraph that's up here, but I'm just going to go straight to the problem. Write an equation for the line tangent to the graph of h at t equals 0. So we want tangent at t equals 0. And then it asks us to do something else afterwards, so I'm going to come back to that question. But for part A, I need a tangent line for this differential equation. So I know I'm going to use when t equals 0, and I need to know h of 0, where 0 is the t. So I'm going to look back up into the paragraph and see if I find an h of 0. Oh, right here, it's 91. That is our y value in our point slope form, and the t equals 0 is our x value in point slope form. So the only thing I need is the dh, so I need the derivative when t equals 0. So that would be negative 1/4 h minus 27. Now, the h value is given by h when t equals 0, so that's 91. So that gives us negative a quarter of 64, which is negative 16. So that is my derivative when t equals 0. Therefore, I have enough to do my point slope form. So y minus, again, that's the h value for this specific t value of 0, so y equals 91, times our slope, which is negative 16, times x minus our t value, 0. So that is the tangent line. So let me just go back. This is the derivative. That'll give you my slope. And remember, this is an h in the function, so I'm going to use the h value of the function at my particular t value of 0. So then I go back and reread the problem. I've done the equation of the tangent line. Now I need to use this equation, the one I just created, to approximate the internal temperature of the potato at t equals 3. So we're doing a problem about temperature of a potato. So don't get too caught up about what's going on, just do the problem itself. So I need t equals 3. We're using this equation here, so I'm going to replace t or x with 3, and everything else stays the same. Y minus 91 equals negative 16 times x minus 0. There we go. And then solve for y. Negative 16 times 3 is negative 48. Add 91 to both sides, and we get an internal temperature of the potato of 43 degrees. And if we look up top, we're working in Celsius. So this should be 43 degrees, degrees Celsius. And if they give you units, you should be using those. Part B asks us to use the second derivative, so that's an indicator right there that we need to find the second derivative to determine whether our answer in part A is an underestimate or an overestimate for the internal temperature. So I recommend that you guys pause the video right now and see if you can find the second derivative, and then see if you can answer, is it an underestimate or an overestimate? So go ahead and pause. Okay, hopefully you pause. So now I'm going to try it. So I need to find the second derivative. So I have the first derivative, dH dt. And to find the second derivative, I just take the derivative of both sides. Comes out with d squared h, dt squared. Now when you're taking the derivative of the right side, remember that h is not an independent variable, it's the dependent variable. And we can see by this notation right here, h is the one on top. So when we take the derivative of h, its derivative is actually dH dt. So we get the second derivative is equal to negative 1/4 the first derivative. And that's because if we look at the first derivative, we just need to distribute the negative 1/4. And when we take the derivative of this entire piece, the 27/4 constant goes to 0, and the derivative of the first term becomes negative 1/4 the derivative of h. And when we get to this point, we know that the first derivative is equal to this entire thing. So I'm going to substitute that for dh dt. And you can see that here in blue. So this is our dh dt. And I'm just going to distribute this negative 1/4 to get 1/16 times the quantity h minus 27. So now I found the second derivative, but it's also asking me to use this second derivative to determine if my answer in part A was an under or an over estimate when t equals 3. So normally what I would do is substitute t equals 3 into my second derivative to see what kind of a value I get back. But the problem is I don't know what h is when t equals 3, so I don't have anything to plug in here. Therefore, I'm going to basically try to determine what it's asking me. So underestimate versus overestimate using the second derivative. Well, usually when we have a derivative and we're trying to figure out the type of value, we set it equal to 0. So I'll start with that. By setting it equal to 0, I can then determine where there might be an inflection point. And if I solve for t by multiplying by 16 on both sides, and then adding 27 to both sides, I get that our possible inflection point happens when the h value is 27. So where does that leave me? Well, let's take what we know. I know that h of 0 is 91. And looking above, we also notice that it says that h is greater than 27 for all t greater than 0. So if the inflection point happens when h equals 27, but for all possible values of time that work, we can't do negative time, our h value is greater than 27. Therefore, any time we use, any value of h that we plug into our second derivative will give us a positive value, and we can see that by testing 91 in for h will give us a positive value. And that means that our second derivative is positive for all possible values of t. Now this is just the calculus connection. If we have a positive second derivative, that means h is concave up. So let's go back to what we're trying to find. Is our value from the tangent line for part A an underestimate or an overestimate? So if you're looking at a concave up graph, the tangent line, no matter where you place it, will always be underneath the graph. And therefore, we're looking at all of those values surrounding the tangent point. Therefore, this is going to be an underestimate. And what I have right here in the box is a sufficient reason for your answer. So the last part of this question is going to introduce a new type of function. So that often happens where you start off using one function and then they completely throw you off by using a whole new one. Sometimes it's related to the previous one, sometimes it's not. In this case, it's not at all. It's a whole new function. We're completely forgetting about h. We don't need that anymore. So now they want us to find an expression for g. So that we don't have a derivative anymore. Now, I know some of you might say, oh, just isolate this g, but the problem is we don't know what this is equal to. So what you can do is think calculus, you have the derivative, you want the original function, we need to integrate. So when you have a differential equation, the first thing you want to do is separate variables. So all the t parts need to go to the right side, all the g parts, since this is all connected, we need to bring this entire thing over to this side. So I divide the entire right side over to the left. You could have left the negative if you wanted, but this whole set of parentheses with the exponent needs to move to the left-hand side. And it's in terms of g now, and then the right-hand side is only in terms of t. So at this point, I've separated my variables, so I'm going to integrate both sides. And to make it a little bit easier on myself, I'm going to take that negative and move it outside. And then I'm going to bump that set of parentheses up because it is an exponent that's other than 1. So now it's negative 2/3 exponent. and then bring down the right side. And now it's easy to integrate because I have something with a derivative of 1 raised to an exponent, and then I have a simple right side. So remember, when you're integrating, you add 1 to the new exponent and then divide by that exponent. So let's clean that up a little bit. And don't forget your plus c. And that leads me to our next step. If we have a plus c, we might have been given an initial condition such that we can find what the c is. And sure enough, we know that when t equals 0, g is 91. Now you can solve for g and then find your c value, but since I'm already here and c is almost completely isolated, I'm just going to go straight into solving for c. And as you can see, the right-hand side is going to simplify to c already, so therefore I just need to simplify the left-hand side to figure out what that constant of integration is. So it would have been a lot more steps if you had gone through solving for g and then finding what your c value is. So I highly recommend, once you integrate, go straight into finding your constant of integration value using your initial condition. So by finding our c from this step, we get that c is -12. And I'm going to go back and plug that in for the c from the equation that I was just using, this one right here. At this point, a lot of people think that they can stop. However, if you go back and read the directions, it asks you to find an expression for g, meaning it wants you to get g equals. So therefore, we need to isolate that variable. So I'm going to divide by -3 on both sides. And I'm actually going to leave the right side without simplifying. If you're not doing a problem that requires you to get an actual answer, you're better off not doing the actual math and just writing what's supposed to happen, because you're more likely to make an error if you do more steps. Therefore, I'm just going to say what's happening and not actually do it out. And remember, if you're trying to eliminate an exponent, you raise everything to the reciprocal power. So I'm going to raise everything to the 3/1 or the third power, and that'll eliminate that exponent on the left-hand side. And the last step I need to do is to add 27 to both sides. And I have my expression in terms of g. Now, if you had solved for c after getting g isolated, your c value would be a little bit different than mine, but the expression would simplify to the exact same answer if you do it all out. Now, anytime you're working on a free response problem, you always want to go back and reread the question. Once you've got your final answer, go back and say, did I get the actual final answer? Did I answer all parts of that problem? And we'll find that this problem has one more step. They want us to find the value of g when t is 3. Therefore, we're just going to take the 3 and substitute in for the t value, and then we're done. Now, this is one of those problems where you need to actually find an answer because it says find the value. So we're going to subtract. We get -9 over -3 cubed plus 27. That becomes 3 cubed plus 27. 3 cubed is 27, so 27 plus itself is 54. And since this is a free response problem, I'm going to provide my answer in a sentence just so I'm sure that I've given all the information. So the internal temperature of the potato at time t equals 3 minutes is 54 degrees Celsius. Notice how I've used both units, minutes for t and degrees Celsius for g. And when I say the time, or when I say the t value, I say the time t equals 3. I'm not sure if that's a big deal when it comes to AP readers, but anytime they provide their solutions, they always say at time t equals 3, not just at t equals 3 minutes, but they say at time t equals 3. So I think it just clarifies things a little bit. So that's it. Here's another example of a free response problem when it comes to related rates and differential equations. If you guys want to pause the video and try to solve it, I will put up the solutions at the end of this video. Here are the answers from the apcentral.org website. Go ahead and take a look. If you have any questions, let me know. And here is the only other differential / related rates equation that has been asked in recent years on the free response part of the test. So go ahead, pause this one, try it out, see if you can do it. And here are the answers. If you have any questions, please let me know. So this has been an up-and-coming topic, differential equations / related rates when it comes to the free response questions. So please make sure that you practice these. If you have any questions, just let me know.